Thank you all for coming along. First of all, I have to apologise, I don't know any German, so I'm afraid I'm going to be talking in English. I'm from a company called Nearform. I head up engineering there, and Nearform, we're based in the Irish Republic, in Ireland, although we have some business and some customers here in Germany. So I'm delighted to be here in Berlin again. What I'm going to talk about today is strategies for handling complexity and innovation in microservices. So what I'm going to cover, I'm going to talk about why I think microservices are a good idea. We've been doing microservices for quite a while. I'm going to talk about an example project that we delivered using microservices. I'm then going to walk through and explain something about the tooling that we use to deliver microservices, particularly around the DevOps aspect. And then I'm going to go through a worked example and do some code examples, and hopefully you'll find that useful. So just to kick off then, I guess most people have heard of the Gossamer Albatross. It was the first human-powered plane to cross the English Channel. What's that got to do with microservices? Well, the challenge was set in 1959 by a guy called Henry Kremer, and he offered a £100,000 prize to anyone that could cross the English Channel under human power, under the power of just the human body. And many people tried to do this and failed miserably. And one of the reasons why they failed was because they were doing a lot of upfront design, spending a lot of money on building something that they thought could cross the channel, and then failing. And the guy that eventually succeeded, a guy called Paul McCready, realised that the solution lay in not trying to do a lot of upfront design, but in being able to fail fast and iterate rapidly. So his process was to build something that was cheap and light and fast, try and fly it, and have it fail. And when it failed, he learned something. So he went off and built another one, and another one, and another one, and was able to iterate incredibly rapidly. And that rapid iteration led him to succeed in building the Gossamer Albatross and crossing the channel under his own power. And I think that's analogous to the way, or to some of the benefits that microservices bring. They allow us to iterate very rapidly in our systems when we build systems. I know certainly from empirical knowledge that when you start building a software system, you don't know everything up front. And the problem with when you're building monolithic type systems is that over time they become more and more difficult to change. And as you begin with bad knowledge in the first place, then changing that over time becomes more difficult. Whereas if you develop a system which is easier to change, which is optimized for delete, so you can remove pieces of code very quickly, you can replace them and update them in your live system rapidly, you're able to deliver systems much more successfully. So like I said, I'm from a company called Nearform. We started in 2011, and we actually started working developing systems in Node.js, so full stack JavaScript applications. And in our first project that we delivered for a national newspaper in Ireland, we were actually building a microservice system. We didn't know it at the time. Nobody had given it that name. We didn't know that was the name of the architecture we were using, but that's what we were building. Because we were led to that type of architecture because of the structure of Node and how it's put together, that led us naturally to build several independent processes that were very vertically siloed and that were easy to change and acted as a microservice system. It was only later when we met with Fred George and started hearing his talks around microservices that we realised that that was in fact what we were doing. So we've done about 50 production systems now, and we're learning all of the time in the systems that we build. We are, well, I guess as a company, we're iterating around that idea, and we're learning more with every system we develop on how we can better produce and better tool up for microservice development and production. So what I'm going to do is just go through a few of the lessons we've learned, and then I'll get into some code in a little while. So first of all, I guess one of the key lessons is to design for iteration. If you want to innovate rapidly, you need to have rapid feedback cycles, and you need to optimize your code for delete. You need to be able to change very, very rapidly. And in the same way that the Gossamer Albatross had very rapid feedback cycles, something like the Titanic had very slow feedback cycles, right? One fail. Design your systems for measurement. If you're going to iterate rapidly, you need feedback loops, and you need to be able to measure what's going on in your system. And by measurement, I don't necessarily mean things like, as DevOps people, we might think of things like measuring the CPU load, we might think about the network load, the throughput, and so on. Those are all really important things. You need to know at that kind of level how your system is performing. But there's another kind of level of measurement that you need to get to, which is the business outputs or the business throughputs in the system. So for example, if your system is processing transactions, you need to know the rate of transactions through the system. You need to know what that looks like, or the logins. What are the logins per hour or per minute on your system? What's the rate of registration on your system? These are all key measurements. These are key business measurements that you need to understand when you're operating a system, so that if you're making changes, if you're doing continuous deployments, if you're rapidly deploying, you can measure these business outcomes and realize when something is having an effect on your system. That's a really important thing to get to, is the high level measurements. So microservices are effective because they break down the barriers to rapid innovation. These statues I like this picture of these statues. If you think of the stone as being the statue forming as the software being formed, and the stone as time, then as time is chipped away, you're never going to get it back, right? You're never going to get it back. They also give you development speed. Speed of development is really, really important. I mean, I don't know how many quarters it takes to deliver a CEO initiative. It depends on the initiative, right? But everybody wants to get their systems into production faster, and everybody wants to see results from their systems faster. Okay, and what we aim to do when we're building a project is to rather than look at the horizontal development and say we need this piece of functionality, this piece, and this piece, all built. We aim to get a system into a production or staging system within the first week. It might not do a lot, but it gives us a platform on which to continually then deploy and to iterate on. So getting something into production as quickly as possible is really important for us. Another reason why I think microservices are something, if you're not doing, you should be looking at doing, is they mean less code. Less code is always a good thing. I think as people that write software, as we kind of go through our careers, we might start off by writing lots of complex code, and then we get to the point where we realize, do you know what? If I can write less code, I'm actually going to be more effective. There's an interesting metric in a book called Code Complete. If you haven't read that book, I'd highly recommend it. I think it's by a guy called Steve McConnell. And the metric is that the number of bugs per 1,000 lines of code is pretty much the same across language and across platform. There doesn't seem to be any variance. Okay, so as you change from, say, writing code in C or Java or even in JavaScript, the number of bugs per 1,000 lines of code stays pretty much the same. So what that tells us is that however much tooling we try to apply to stop people writing bugs, the bugs are always going to be there. So the best way to reduce bugs is by having less code. Straightforward, right?
But why does it mean less code? I don't get it.
Sorry?
Why does microservices mean less code?
What I mean by less code is, I mean, within the unit of a microservice, you should keep that very, very small and understandable. Right?
Yeah, well, but
so if I'm not...
You have more microservices than one.
You have more than one microservice, of course, right? And so you may have a large amount of microservices, but within that, the context of that one service, you've got a small, understandable set of code. That's the aim. If you've got something like the definition we like to use is that it's a component that can be rewritten within a week by one developer, right? So if you reduce the coupling and you can reduce the code within that unit, it becomes more understandable, and there's less code within that unit to deal with. So it becomes you reduce the bugs by having less code in that fashion. Does that make sense?
A bit.
Okay. By the way, do please shout if you've got questions or you want to challenge anything in this. Please do. Thank you for that. Okay. So by having small, loosely coupled components, you have this kind of excellent approach to building applications. And we came across it, like I said, in the JavaScript world almost by accident, but we're seeing huge benefits. We have customers doing microservices, not just in JavaScript, but also in Java, Scala, and other languages as well. I guess the other comparison with monolithic applications is that monoliths are hard to deploy. You guys are all DevOps people, so I've certainly deployed monolithic applications in the past, and when you come to that kind of big bang deployment where you've got to deploy your application that's gone under tests for a long time and it's an all or nothing deployment, that can be quite nerve-wracking. So by moving to a smaller componentized model where you can do more continuous deployments, you reduce a lot of the risk in those deployments, and a lot of the stress and pain that I've certainly felt in doing large-scale deployments. So really what we're looking at supporting with microservices is small, agile, adaptable architecture, supporting partial and continuous deployment. So we should be able to push out a single microservice or several microservices at a time without affecting the rest of the system. And that's a big change from doing big bang type deployments. So as an example project that we've done, obviously we put a lot into production. There's some we can't talk about. This one we're okay to talk about. This was a digital transformation for the London School of Marketing. And what these guys do is they sell marketing courses online, so you can sign up to their system and you pay to run a course. It's all e-learning, electronic delivery of content, and people go through learning and come out with qualification at the end of the process. Now, this was the challenge that we took on this project. We had a very tight deadline. It was 12 weeks to deliver. There were 3 companies involved, one of which was ourselves, working across 6 countries, running a 10.5-hour time zone day, 9 developers on the team, 8 had never used microservices, so we had one guy in there who was running as the kind of delivery architect on the project. Most of them had never met each other, 5 had never met each other, 3 of them were new hires and 3 spoke no English at all. In an English-speaking company, that's a challenge, right? Would you have thought that would have been a successful project? No. To be honest, we almost didn't take the project because of the challenge was so great. But actually, by applying the principles of getting a system up into production very early on, and then iterating around and adding functionality by using microservices, we were able to successfully deliver that project on time, even with those constraints. So this is, as I say, this is something that we do on a day-to-day basis, and it does work and it does give results. I think had we taken that on and built it in a monolithic way, it may have been a failed project. I can't know. We'll never go back and reverse time, but it certainly helped us in delivering that project and working against those challenges. So here's some of the challenges that people often raise when we talk about microservices. One is that the system becomes too unwieldy or complex to understand because there are a lot of moving parts. Another is that the local deployment doesn't necessarily equal your staging, doesn't equal your production deployment. Other people think that the system's not deterministic, testing is less effective, and the architecture is hard to describe. Is there any other points on microservices maybe you'd like to bring up? Not a fan, no?
No, I like microservices for scaling. Generally, it poses a lot of more complexity to the submin, so the operation.
Sure, yeah. Okay.
No transactions.
True, absolutely. Well, I suppose you could, but it would be a very complex thing to do, right?
That's not a microservice.
Yeah. Sure.
And you have some point when you have very much microservices and they have to communicate with each other, you can get a problem with the actual latency between the communication so that the software gets slower because you have much microservices. Because of the latency.
Could be an issue, yeah, absolutely it could, yeah.
So if we assume microservices is not for just one project, but if you have many microservice components in your architecture and you're doing this for a few years, and you say you can take a microservice and re-implement it, how do you track who is using that service? And what kind of API compatibility you have to provide for the new service?
Yeah, so the way we approach that is that we wouldn't reuse microservices per se across projects. What we would do is we would write component libraries to do a job. So in our case, they would be like node modules. So those would be just standard libraries that we might want to reuse. We publish those up to NPM. And those, again, would be very kind of tightly focused libraries. But we would reuse at that level rather than reusing at the actual microservice level. So we wouldn't take a microservice that we developed on one project and use it on another. We just write fresh services. But the underlying libraries that may be used by those services is the level that we would share at. Yeah. Okay. So how do you survive microservices? Well, the way we do it is that we think about messages, not services. So we think about the message passing between those services and try and identify, as we're developing the system, what those messages are, and develop almost a pattern language or a domain language through those messages for the system. We try and automate everything we can, wherever we can, and we also prefer adding services to mutating and changing services. So for example, if we have a service that calculates sales tax for Europe, and we need one for the US, then we'll write a US sales tax service and deploy that into the infrastructure rather than changing and redeploying the existing European sales tax service. I've got an example of that in a minute. We monitor the message flows and we optimize for delete. You should be able to delete a component from your system and re-implement it within a week. If your services start to get too big and too complex that you couldn't, one guy couldn't re-implement them in a week, then you're doing it wrong. They're too big.
Short question.
Sure.
When you say to use two sales tax services, for example, in the US and Europe, and you have an issue where you should have to scale the services, you also would like to have something to discover what services are available.
Correct.
So you use also the services company to achieve what is in our environment and what can we use.
Right, yeah, so I've actually got an example of that in a minute, but just to bring out the point though, we went through a process as we were learning this of writing deployment systems for customers, and those would have been bespoke, scripted each time. And after doing that 2 or 3 times, we figured that we didn't want to do that again, and we put the knowledge into a tool, which I'm going to show you in a minute. And one of the things we actually learned in doing that was around service discovery. That service discovery is actually quite a difficult thing to do. And we tried using things like, obviously just using DNS is one way of doing it to discover hosts. We've used things like console, etcd as well to do that. We're interested at the moment, and I have an example of this in a while, of the concept of using a kind of overlay network for service discovery. So the intent there is, or the idea is that a consumer of a service doesn't need to know the host name to talk to. All it needs to know is a port mapping, so what port to talk to get to a service. And that can be, what we're doing is injecting that into the service, into the service's environment. It's important that a service executes in a context whereby it's just dealing with messages. It shouldn't know anything about its execution environment per se, so whether it's getting its messages over RabbitMQ, whether it's getting its messages through point-to-point HTTP or whatever, we try and abstract that transport layer out. But let me come on to a concrete example that might make it a little easier. So in kind of surviving microservices, I guess there's three things that interplay together, right, at a high level. There's the development language that you use. Of course, microservices should be development language agnostic. We just happen to use Node.js because it allows us to work very rapidly, but we do have systems that blend languages together. The frameworks that you use are very important. The framework will set out your kind of approach to how you develop microservices, and obviously the DevOps tooling that you use has to be aligned. Those three things are critical to have those kind of aligned together. So as I said, JavaScript, I'm a big fan, but you guys have probably used other languages and tools. That's fine, whatever sells your boat. In terms of frameworks, we use a framework called Seneca.js that was developed by one of my colleagues. And Seneca provides two very, very important things for microservices. One, it provides transport independence, so it abstracts out the transport layer. So your services don't know or care where they're getting their messages from. They're just receiving and responding to messages. And then it provides a very simple pattern matching library, which allows for routing of messages. And if you want to find out more about that, look at senecajs.org. I believe there are similar frameworks in other languages that aim to do similar things. So with regard to the DevOps then, you really need an appropriate toolchain for microservices. That's either, and as you guys are probably aware, there's a number of tools that are becoming available to do this. Nscale is one of those tools. And we built this on kind of three principles after having gone through the loop several times in developing bespoke deployment systems for our customers. One is that everything is containerized. So the way the tool works is that it treats everything as a container. That's not just a Docker container. We'll treat processes as containers. We'll treat AWS instances as containers, or even security groups as containers. So it's containers all the way down. The second point is that it's around immutability. I guess it was Netflix that set the kind of standard on this in doing immutable deployments and spinning up instances and then swapping them out into production, doing kind of blue-green or canary type deployments. So the principle of immutability and moving containers through from development through staging and production is really important. And the other principle is around homeostasis. And what I mean by that is that the ability of the tool to measure what the current production or staging system looks like, and then to bring that back into line with your desired state as specified in your configuration. So let me go away from the kind of high level stuff, and let's just go into some code examples. So when I was thinking about complexity, my mind naturally went to tax. I know when I was filling in my last tax return, I think it was more complicated than writing software, right? So we're going to look at building a system that computes sales tax, and we'll do a generic tax service, and then we're going to move into looking at EU and then US sales tax. US sales tax is really complex. I didn't realise that until I looked at this, but there are some very arcane rules around tax computation, particularly for clothing and so on. So what I'm going to do, I'm going to sit down now because I need to get some code going. So the tax really, it's a simple enough calculation. It's the net times the rate gives you the gross. But how you get the rate can be quite complicated. So what we're going to do is work with the pattern language for this based on JSON. So if you look there, we've got a message that a service might receive. It's got the role sales tax. It's been given the command calculate, and then it's given the net value of 100. And as we develop the system more, we can add more into those messages by adding in things like countries and categories into the messages. Incidentally, it's important in terms of microservices that they adopt the rule of being very flexible in what they intake in terms of their messages, but being very strict in what they output. So if you've written one service that understands how to deal with sales tax and the calculate command but doesn't understand the category or the country code, that service should still operate in the context that it gives them a message with additional features on it. So what we're going to do is we're going to build a system. We're going to deploy some bare processes to begin with. Then we're going to put a staging system together and deploy some containers. And if we have time, we'll push out to Amazon. So we're going to create a pingable API server, just a simple ping service. And once we've got that deployed, we're going to create a basic simple sales tax service, and then we're going to deal with EU tax and then US sales tax. So first of all, we'll create the system. So this is the result of doing a system create. Let me just see if I can get this. Okay, great. Okay. So what I've got here is a number of steps. Sorry, go ahead. Sorry? Yes, of course, yeah. Hold on one second. Sorry, 1 second now. Oh, sorry, can you see the pointer there? I'm just trying to... No. There we go, I think I got it. There we go. Is that better? Bigger again, yeah? Is that okay? Can you read that?
Can we close the other curtains maybe?
Sure, yeah. Are these Get away. Electronically controlled? What? Yeah, come down a little bit. Okay. We use clouds, look at that. We all use the cloud, right? Gotta love it. Sorry, I actually, does anybody else want to have a go? Because I can't move those curtains myself. So.
Near the door, maybe.
Give it a shot. We believe in you.
It's just far too sunny here, right? Okay. Can everyone see that?
Yep.
Okay, super. So what we've done is here is created a system definition, and it's consisting right now of just two files, system.js which contains some information about the service the system we're going to run, and a topology. And at the moment, the topology is completely blank. And then I've got an area here where I'm going to define my services, and at the moment, all I've got is a blank container. So I've got an empty root container there. So in the first step, I'm going to create a pingable API server. So in order to do that, what we'll end up with is a topology with a single service sitting inside it, right? Really straightforward and simple. So if I move forward into that step, you'll see here that what I've done is I've added a container here to my topology. And then I've added that container definition here. So the container definition contains a few things. It contains a shared section which links to my code. Okay, so this is linking to a repository on GitHub. And then I've got, I'm telling it for my development topology, run as a process, use this build command, and execute this as the process when you fire up. Okay, so I'm going to do an N-scale. Type. Scale. Vision. So I'm telling N-scale to deploy the latest development topology for step 1, which is just going to go and spin up that simple process right now. So if I now go to localhost 3000 and hit ping, okay, you can see I've got my ping service up and running. And if we just look at the ping service code, in this workspace folder here, and I'll explain that in a moment, you'll see that's my simple ping service. It doesn't get much simpler than that, right? So I've created something to respond to a ping service on port 3000 and added it to my topology, okay? So in the background, what's happened is that previous to this, I ran a compilation step with N-scale, and what that did, if I can explain to you here, is the way that N-scale works is that on the left-hand side here, we have our code. You're typically living in a Git repository. N-scale is able to pull and build that code into container images. And those container images can either be processes, it could be Docker images. On the other side then, in terms of deployment, what N-scale does is it analyzes its current environment. It does a comparison between that current environment and the desired environment state. And the desired environment state in this case is just one process running. It then generates a plan, and then it executes that plan to run its deployment. Okay? So that's its complete cycle, and this is the idea of homeostasis, in that you analyze the state of the system, you compare, you generate a plan, and you execute the plan. Now in this case it's not very interesting because it's only one service that we're deploying, so we'll go forward and make it a little more interesting. The other thing to point out is that N-scale is Git-based, so every revision to your system that you make is committed into Git. So as you change your system topology and you change the containers that are in your system, that's all tracked in Git, so you can roll back to point in time. So that's built in. And that was something that's really important to us, is the ability to have immediate and safe rollback to a known state. Okay, so let's move on to step 1. What we're going to do is just create a really simple sales tax service. This is going to be a microservice, and we're going to link it up to our front end. So we're going to end up with this topology now. We're going to add a staging topology in, and we're going to have development and staging. and the service is going to run as a container in the staging topology. So let me just show you that now. So I've now created an additional topology here called staging, and I've added my front end to it, and I've also then added my basic service to it. If I go into my definitions here, in services, you'll see that I've added a new section into the front end service, and I've told it for type staging, run as a Docker container, apply these arguments, and execute this inside the container. You'll note then also that I'm using a similar repository URL, however I'm now pulling from a different branch because I've updated my front end for this demonstration. And I've got a similar structure for the basic service in that I'm telling it to run as a Docker container on staging, and then I'm pulling from a second repository where my sales tax service code lives. So previously to this, because I don't really trust conference Wi-Fi when I'm doing demos, I pulled down, I ran a compilation process with Nscale, and that pulled down this code. So as you can see here, it's pulled down the step 2 branch for my sales tax front. This has got some minor changes in it. And then it pulled down my service, which is pretty straightforward. It's just doing a calculation. Okay? And then returning the result back. And again, this is all using Seneca. So what I'm going to do is dev, because I think that's still running. So I just killed it. Check step 2. So what I've done now is I've run a check, and what that means is that previously to coming in here, I deployed the step 2. So Nscale knows the state that the system should be in, and by running a check, what it's gone and done is done an analysis, found out that the containers are not running, and said that what I need to do now to correct that is to run these 2 containers to bring the system back into line with the desired state. So I'm just going to run a fix to bring the system up. And if I run the check again, you'll see that the system is now in line. And just to prove it, you'll see there's 2 containers now running. So if I now go here and hit my ping service, incidentally I'm using boot to Docker here, so this is the boot to Docker IP address on this machine. So let's hit this with ping. Great, so I've got a ping, and now I'm going to hit it.
Not visible on the project, you can't see.
Oh, I'm sorry. Going too quickly, my apologies. Let me just move this window across. I can see it here. What do you mean? It works on my machine, guys.
You don't trust it.
Of course. So there's my ping, and this is going to be tough. I thought I had all sorted with tmux and everything. Let's do price. Let's do that one. 100. Okay, and I've got a result back, so it's calculated the sales tax value there, right? Okay, so just to bring out what's going on there, okay, we've got a number of repositories on GitHub, in this case just 2 at the moment, and we've got a system with our container definitions. And those container definitions are linking to these repositories. We've just told it a URL. Now when we run a compile, what happens is that Nscale will go and fetch the latest revision of that branch and generate the compile. It'll then keep that compile in its own Git repository. What that means is that as you roll the system forward, if you want to go back to point in time, you go back to the Nscale a previous commit revision, that will link back to all of your other software assets, to the exact SHA revision and branch that you pulled in and built at that point in time. So going back to point in time, even if you've blown the containers away, as long as your Git history is still there, you can rebuild at point in time. Now normally, to be honest with you, we roll forward rather than rolling back, but sometimes we need to roll back, right? But generally we would try and roll forward and put a new fixed version of a service in place rather than rolling back. But that's what's going on there. Okay, so what we'll do now is I'm just going to clean up the code slightly, and I'm going to now run 2 instances of sales tax basic and load balance it. I know this is running on a local system, so if I now roll forward to step 3, you'll see that what I've done is I've added a sales tax basic, two instances of the sales tax basic service now into my staging topology. And in my definitions, what I've done is I've added some settings here. I've added a proxy port. So I've told it that sales tax basic is still using Docker, but that it should use a proxy port and it should auto-allocate port numbers, right? So as you'll note, the previous set of arguments that were being passed to Docker are now no longer required. The port allocation is happening automatically. So let me just go ahead and deploy that. So just kill the old system. Yeah, it's definitely dead. Okay, so end scale. Okay, so I'm now going to deploy the staging version of step 3. So, and you'll see now there's an additional step where my proxy's been hubbed. So if I now run Docker PS, you'll see that what's happened now is that I've got 2 instances of my sales tax container running. I've got my front-end container running, but I've also got this proxy container running. So what Nscale's done in the background there is it's automatically pulled in this proxy container. The proxy container is running an instance of HA proxy, and what Nscale has done is it's taken from the system definition, it's auto-allocated port numbers for each service. It's generated a HA proxy config, injected that into the container, so that now my services only need to talk on a port number. They don't need to know the address to talk to. They all speak on their own local interface and just talk to a port. Now, the other thing that Nscale has also done is it's injected environment variables into those containers, which give all the port mappings. So if I show you if I go back to the code now, you'll see that in step 3, if we look at the sales tax basic service, you'll see that this code now is listing on is using 2 environment variables here, the service host and the service port. And those will change as Nscale spins up multiple versions of that container. Those environment variables will be different for each container, and they're injected by Nscale into the container. So we've now got 2 instances of this service running, and requests are being balanced across that service. If we look at the front-end service, I've made a small change to that to allow it to consume these services using environment variables rather than the hard-coded port mappings. So if you look here, Nscale has generated this proxy host environment variable, and then this environment variable here, which is which tells it where to find the sales tax basic service, so which port to consume that on. And again, this is listing on its own service port and service host here. So just to prove that is indeed running, if we come back to I should be able to hit that. Okay, so it's actually up and running and balancing across those two services. Were you guys seeing that at all? You saw that? Okay, yeah, cool. Okay. So the topology now looks like this. We've got a front end calling through a proxy, and we've got two instances of our basic service being called. And in the background, what's happened is that compilation step has created our images, and then the deployment has injected the environment into the containers, and then reconfigured our HA proxy container with a configuration that was generated automatically from your topology. So the next step, things are going to get a little more complex again. We need to handle European sales tax. So instead of rewriting our basic sales tax service, we're going to create a new European sales tax service and deploy it into our environment. So once we're done with this, our setup will look a bit like in the bottom picture there. We'll have a front end talking to a proxy, and that will be consuming the basic service and then the European service, depending on the message patterns that are being used. So let me just run through the code there. So if we start at the top on the topology, you'll see that I've now added in I've got two sales tax basic services there, but then I've got my EU sales tax service as well. And in order to do that, I needed to add something into my definitions. So I didn't need to change the front end or the basic definition, but what I did do was to add in the sales tax EU. And again, this is talking to my sales tax EU GitHub repository. So I've now got three kind of code repositories, or three artifacts, one per service and one for the front end. And you'll see that I've not had to touch the sales tax basic code at all. So my original microservice is still running. I've added in this rather simple EU computation service, which I'm afraid to say only deals with Ireland and the UK. I should have added a DE there, so I do apologise. I've only had to make a small change to the front-end service to tell it to consume the EU service. And again, this is where Seneca is abstracting things for me. By telling it to match on these patterns, on UK and Ireland, Seneca will automatically send or consume the EU service when it's given that pattern, and when it's just given the basic pattern, it will revert to using the default service. So let's go ahead and deploy that. Definitely dead, okay. So there's a few more containers being deployed now. I'll just check that everything's okay. Okay, and just the Docker PS to prove it. So you can see all the versions of the containers running there, the environment's being injected, and the proxy container running. So let's just hit that service now. Yep. Where is it? There we go. Not home. I'm just going to change it here. There you go. So I've hit that, and I've now added the country argument of UK there, and you can see I'm getting 120 returned, which is the UK sales tax. Now if I remove that from the end, should see now that I drop back to the original microservice. So based on those pattern matchings, we're calling either the original service, which has been deployed and remained untouched, or the new service that's been deployed into our infrastructure, both of which are being consumed through this overlay network, through HA proxy. Okay, so let's see if we can make it even more complicated. We now also have to take care of US tax, so we're going to add more complexity into the system. So we're going to add yet another service, okay? And once we're done with this, our system is going to look like the picture on the bottom there. We're going to be consuming through the proxy. We'll have our standard sales tax service. We'll have our EU service. Both of those are going to remain untouched. And then we're going to have our US sales tax service. So let's go and have a look at the code for this. Step 5. In step 5, I've added in my US sales tax service. Actually here I'm only actually running one instance, but it doesn't make much odds, it's the same thing. So I've got 1, 2, 3 services and a front end. And again, you'll see here that the US sales tax service is linking to yet another repository with a new microservice sitting in it, and it's got auto port allocations going on. And again, you'll see that those artifacts have been pulled down by Nscale and the containers built and then deployed. So let's go ahead and deploy this. Let's kill the whole system. Okay, so we'll just do a check that that's all running okay. Okay, that all looks good. It's up and running. So let's add in some additional on the end of there. So let's say we pass in 100 as our net, and this time we're going to put in US. So that's giving us 0 for the sales tax because the default is to return no sales tax. But if we now add in a state to that, sorry. We can see that we're getting a result back from New York. And if we try another state, Alabama, we can even give a city code here. We've got a bit of a rounding error, but we're getting a result back, okay? So we've added more and more complexity into the system, and the way we've done it is by adding additional services, but trying to tame that complexity by using this overlay networking idea and having an appropriate tool to manage that complexity for us. Okay, so I'm going to be brave now. The last step is to push the system up to AWS. So I'm not sure whether we'll get a decent enough connection, but in an AWS deployment, what we're doing is we actually have a couple of instances. So we've now distributed the system over a couple of AWS instances. We've got the front end, and in that case where you're running multiple machines, you'll have a proxy on each, and the front end is talking through that proxy to instance 2. I'm not sure what my Wi-Fi is like, but I can show you the code anyway. So in step 6, what we've done is we've created a new topology. So in the point of a real project, this would be the stage where we've got something up and running, we've got a few simple services up and running, and now we want to deploy into a live environment for testing or for the client to see. So what we're doing now is we've added this production topology in here, and within that production topology, we've added this container. This is a security group container, and that contains our front-end machine instance, and it also contains our basic EU and sales tax for the US services on a separate machine. What I've then done is I've added an AWS configuration here, which is a little messier. But what this does is contains the actual AWS API definitions for the security group, and it gives us a machine image or instance ID to deploy onto. So I deployed this earlier this morning, and Scale span up the machines, created the security group, and then deployed the containers into that security group. But I wasn't brave enough to do that live because spin up time can be a little slow on Amazon sometimes. Okay. The additional thing I've then done is just to add some configuration in here, which includes things like the access key. I'll delete these now you've seen them, and the I trust you guys, it's all right. And other bits and pieces that are specific to Amazon. Okay. Okay, so let's see if we can, in fact, let me see now. Okay, we're in. So now I'm running a check against step 6, against the production environment. This will be a little slower. Okay, there we go. So what it's done is it's gone off and looked at the machines that it knows are under control. It's run an analysis on those. It's come back and realised the containers aren't running. So if I now do a deployment, if I do a fix, we should see those containers being spun up on those 2 machines. And I just want to check again. Okay, so I come over to there it is. Okay. There we go. Okay. So that's just one of the raw IPs of the front-end instance there, and you can see the US sales tax service being called. Okay, so I think I'm running up to time now. So just to summarise then. We created a simple front end, we created 3 microservices, and when we independently deployed them, one after the other, adding more functionality and complexity into the system, but we managed that using Nscale, and then we deployed into a staging environment and then onto AWS. So in summary, as an organisation, we believe that microservices provide huge benefits for continuous and rapid innovation. But your DevOps tooling has to be aligned. And Nscale is one example of a tool that allows you to manage microservices. There are others out there, and if you're in the business, or if you're looking at having to deploy a microservice-based system, then I'd really encourage you to get the tooling right. Have a look at Nscale. By the way, it's open source. And we value pull requests, so if anyone's interested in contributing, we'll be delighted to have you on board. And these are the tools you saw today. So Seneca Framework, Nscale, built on Node and with Docker containers. That's it. Thank you very much. Any questions? Sure.
What's about zero deployments?
So the way that Nscale works is it's doing algorithmic type deployments. So we would, in that case, you would have a load balance at the top end talking to your front end, maybe multiple front end instances. You can configure it to actually say, okay, take that one instance out of balance, switch the containers on there, flip it back into balance, and then sort of ripple that effect through all of your instances that are participating in that load balance. So that's kind of the approach we take for that. What's the question?
Within the landscape framework?
Yeah, it's part of it. So we actually have a simple deployment algorithm which says just deploy, don't care about order, and then we have a more complex deployment algorithm which is kind of a safe deployment, and that safe deployment says ripple those changes across and make sure you don't like bring anything down as you do it, which is slower to do, but yeah. Sure.
Can you show us the language of the services?
Probably, yeah. Yeah, sure. What do you actually want to see? Okay. So I haven't got any monitoring on these containers or.
Do Docker stats.
You want to do Docker stats, yeah? On any specific container? Sorry.
How much of this containers you would run on a microservice, for example?
It would depend. Sorry, I know it's the get out of jail answer, right? But, so what was the question, on a micro instance or on a... Again, it would depend on how much memory and what they're consuming. On a micro instance, generally 1 to 2, right? No more than that, because you don't have much compute power there.
If you add some containers on production, is the proxy image updated also? So are the new points updated?
Yes, so what happens is that on every deploy, if the topology has changed, Nscale will generate a new HA proxy config for each point of the infrastructure. And as the containers are deployed out, it will then send that configuration to the proxy container and hub it on every deploy.
So you don't have a gap in production?
You have a gap, no, it hubs the proxy every time. Yeah.
Great.
Yeah.